University developed a PET resin recovery recycling system for soda bottles and milk bottles, or not milk bottles, soda bottles and water bottles back in the mid-1980s. And when we began collecting material for that, we found that we collected stuff from curbside collection program that had 20% of bottles and tubs that we weren't asking for. And so I started to make recycled plastic lumber from that, figuring that I would make thick cross-section pieces and that there would be a variety of different plastics in there, but it was mostly high-density polyethylene. And we found that the material didn't have very good properties, so we couldn't make anything that was structural out of it. So then we began to try and find ways, without spending a lot of money on the material, to make a structural material. And we got several patents, but the one that we are currently using for this product right now is blending the mostly high-density polyethylene material with automotive bumper scrap. And we found that material can handle a very high stress, about 10 times as high as high-density polyethylene can, with no long-term creep effects or anything, and it's very resistant to degradation, and it's suitable for things like railroad ties and bridges.
The original bridge was built out of conventional materials back in the early 50s using wood piles and a wood stringer system, and it was aged and had deemed to be non-usable, and so we were contracted to replace it, and we decided to go with the recycled composite structure, and that's what we have. We're trying to produce more green projects for the government, and this whole project was basically done with 100% recycled material. The composite material is 100% post-recycled, so we were able to take the material out of the landfills and reduce the greenhouse gas effect if we had been using the wood lumber.
Centennial, our prime contractor, our go-to team, allowed us to use the design build fast track process to get into the hands of the new technology, and they explored the conventional technology, came up with this as a better alternative for the long term for all the reasons that Jim has talked about, and it allowed us to probably complete the process in half the time that we would have used had we gone conventional construction.
As Bart alluded to earlier, quite simply, that we're taking 100% recycled materials and we're pulling them out of landfills and re-diverting them into useful life. If you think back to some of the complaints about landfills, it's that they're pulling milk jugs and things out and saying, hey, this is 20 years old and it hasn't degraded. If you take that kind of negative, turn it around and make it a positive and make it so that that product is going to last indefinitely, it's going to have a physical bond with the other materials we use and not have any preservatives, leach any toxins or anything like that. The green circle here is phenomenal. We use less energy to produce it. We start with recycled materials. It takes less energy to transport because it's lighter and it lasts longer. So that's the magic of the materials.